Hey guys, so happy Tuesday. Today we're going to talk about what happens if we flip the script on what we did yesterday. So instead of me describing these graphs, what if they give me the story and then I have to spit the graph back out to them? So let's say, for example, we have mom leaves home and travels to the store. She shops for an hour, then returns. Right? So what if they give us a situation and we want to come up with what would the qualitative graph look like? Okay? Well, first of all, we're going to have to come up with our x and our y axes. So this is talking about time. It's talking about how long it takes. So like I said yesterday, the x is typically our time. And in this case, maybe we could do it in hours. I don't know. We can do it in minutes maybe. Let's do it in minutes. That'll probably make more sense. And then what do you think our y should be? Well, it's talking about how she leaves home, she goes somewhere, and then she shops, and then she returns. So maybe distance from home. So 0, 0, the point 0, 0 is going to represent her home. And at the beginning of this thing, what's she going to do? So it says that she travels to the store. Now, it doesn't tell us how far away the store is. So we have a little bit of artistic license here that we can kind of be like, well, she travels, she goes away. Maybe you want to make it linear. Maybe you want to make it bumpy like that, right? Because she might travel at a constant rate. She might not. Maybe she gets stuck in traffic and she stays at some constants, right? So maybe she's like this, and then she goes flat, and then kind of goes, flat again, right? But we don't want it to take too long for her to get to the store. So let's do something like that. And then it says she's at the store for an hour. So if she's at the store for an hour, her distance from home is not going to change. So that, I would assume, is going to be a constant area of just a flat line. And we want to be careful here because this is the only place where it tells us exactly how long something's going to take, an hour. So I'm just going to say that maybe a little bit longer than that. Because it's not like it's going to take her an hour to get to the store, right? Hopefully not. Maybe she lives in the boonies. I don't know. So we'll say she's at the store. And then she returns home. So then we know that home is our x-axis. So we want her to get closer to the x-axis. And again, it doesn't matter necessarily how we get there. Just as long as time goes, we're continually kind of getting closer to home. And so maybe that's our graph, right? Maybe that's a graph of how this is going to look. There's going to be some important spots that I'm going to look, like what's going on in the end behaviors. Did you start at home? Did you end at home? Is there an area where there's a constant where she's at the store? Is this increasing, right? She should never be going closer to home if she's driving to the store. You're not going to drive past it and then come back, right? So maybe it's constant if she's in traffic, but it should never be decreasing, right? This interval should be increasing or constant the whole way. Same thing with over here. That should be decreasing or constant the whole way because she should be driving back home. So that's kind of the gist, right? I don't really need to do too many of these, but I'm going to do one more with you. And then obviously if you guys have questions, you can let me know. I think these are kind of fun, or kind of make up your own stories. And they're going to tie in with what we're going to do tomorrow too, which is cool too. So maybe we'll say let's say a baseball player hits a double. He then steals third base. And the pitcher falls apart and ends up walking him home. All right, so this one's kind of fun. So we have this baseball player, he gets a double, and then he steals third base, and then the pitcher kind of just gets crazy, starts throwing bad pitches to everyone else, ends up walking some guys, and then our guy gets walked home. So maybe we'll make this time in minutes. Maybe we'll do seconds. I don't know. We'll do seconds. And then maybe we'll do distance from home. That'll be fun. So he's at home. And notice that he's going to have his at bat. Now, we don't know how long his at bat is. And if you don't know anything about baseball, I'm sorry, I apologize for this. But he's going to be up there trying to hit the ball for a little bit. So that means he's going to start with a constant at 0 here. Right? He's going to stay at home for a while. And then he's going to hit the ball and he's going to run real fast. And second is as far away from home as he can get. So he's going to just keep running until he gets to second base. Let's make that a little bit more fun. Let's make it go. He was going to first and then he really turned it on. Okay. And then he's sitting at second base for a while. So we need another constant because he's staying there. So he was at home, he got a hit, he took off, he went really fast, and he's at second. He's staying at second. And then finally he takes off for third. Now what's interesting here is third is actually closer to home. So he's going to be going this way. And then he's going to stay at third base for a while. Probably a long time if this guy keeps walking people. And then when he walks, he just kind of gets to walk home, right? So it's not, super steep. He's just going to trot on home. So he starts at home. He gets a hit. He's running from first to second. Stays at second for a while. He runs to third. Stays at third for a long time. And finally gets to walk home. So you guys get to come up with the graphs, which I think is really, really fun. Just look for your end behavior, right? What's going on at the end points. And look for not only your increases and decreases, but how are they increasing? Is it a constant rate? Should it be linear? Should it not? Should it be nonlinear, right? Those are important differences that you want to look out for. And then, of course, where is it constant? Where are they just staying the same on those flat parts? Okay? These are pretty fun. I give you guys some practice, and then we're going to practice some more tomorrow, which I think will be really helpful for you guys. Okay? All right, cool. Nice, easy, and quick day. I'll see you guys later.